Hello, I'm Zachary Hughes, and I'm here to show off my little tech demo for multi-object networking using Unity's UNET API in a game called Nanobots, which I made here. Nanobots is a little top-down kind of hide-and-seek shooter game where each side has a grouping of 3 nanobots, which they can cycle through by pressing the tab button, and each nanobot has its own kind of set of attributes. So the basic nanobot on the left moves fast, turns fast, but has low visibility, and has a slow-moving but quickly firing gun. The nanobot on the bottom right, the shield, moves slow but turns very fast, and has a shield that can block incoming fire. And the last one has a very long but narrow visibility cone, and shoots very slowly but very quickly. It's basically a standard shooter, a shield, and a sniper bot. Same thing for the other side here, spawning with the exact same 3 bots, but on the other side of the map. Additionally, whenever a bot is spawned in, or rather the other team's bots, they're flipped to show red, and the visibility cones are disabled, so that way you can't see them. Again, so it's a little more of like a hide-and-seek kind of thing. Instead of flashlights blaring, everyone knows where each other is. Now, the point of this game is to shoot the other team's nanobots. After one shot, they're dead, and it'll display a red grid pattern whenever the bot is offline. Once you shoot down all 3 of the other team's bots, there's really not much else you can do but quit the game, which is why the UI for joining, hosting, and quitting is always present in the bottom left corner. Additionally, this game it handles motion by server-authoritative movement, which is why there's a little bit of a problem with delay, as you can see here for this bot. He moves a little bit slower because he's constantly getting updates from the server where he is and where he should be, rotation and forward movement. Though by doing forward movement only, I was able to cut down a little bit of this, mitigate some of the lagginess by storing both rotation and forward movement in a single Vector2 object. This is handled in the nanobot's bot mover script. Anytime the nanobot moves, every fixed update, it'll send a command to the server with the input axes, the report position, rotation, and its movement buffer. The server then validates it here, and then grabs its connection to the mover's owner, which is this bot spawner up here, which is the actual player object in the game. If the movement is outside the reported range, it will target that specific bot and tell it to update to the new position. Additionally, afterwards, it will send a relay position message to all connections that are not that bot, because if the position is valid, it no longer needs to update that specific bot. To do this, I used the network server.connections object, just iterated through, and compared it directly to the excluded network connection. And by doing this, I was able to send far less messages every single frame. And so, that's my game.